All right, let's take a look at characteristics of the stars. Our learning target is to describe how scientists classify stars and identify how they differ from one another. So we'll be looking at how they are classified and how different stars are different from each other. Let's take a look at the GR. Make sure you add any corrections you need to and add to the class wiki. Imaginary patterns of stars are called constellations. All right. 5 characteristics used to classify stars are by their color, their temperature, their size, composition of gases that make up the stars, and their brightness. And then brightness we'll talk about. There's a couple different categories of brightness. Let me go back to constellations. You probably know like the Big Dipper and maybe Orion and Orion's Belt. Those would be two constellations that are really clear in the winter sky especially. Um, the stars in those constellations are, you know, not close to each other. They look from our perspective that they're close to each other, but they're really, really, really far away from each other. I just want to point that out. All right, 3, what reveals a star's surface temperature? Its color reveals its surface temperature. So you've probably seen a flame that's like orange and then white or blue, and the different colors represent different temperatures. And so same with the stars. Red color of the supergiant called, I don't know if it's pronounced Betelgeuse. I like to pronounce it Beetlejuice because I like that movie. But maybe it's Betelgeuse? I don't know. I'm calling it Betelgeuse. It's a fairly cool star because it's only red in color. The hotter stars are going to be white or blue. Stars that are much larger than the sun are giant stars or supergiants. Our sun is only a medium-sized star. True or false, each element has a unique set of lines on a spectrum. That's true. So when something burns, it has kind of like a fingerprint on the spectrum. And each element, whatever is burning, is it hydrogen, is it oxygen, is it helium, whatever, as it burns, it has a different kind of set of lines on the spectrum. How can astronomers infer which elements are found in a star? They compare a star spectrum with the known spectrum of different elements. So they burn an element here on Earth, and see what its pattern is on the spectrum, and then they compare that to what they get from a star that's millions of light years away. A spectrograph breaks the light from an object into colors and makes an image of the resulting spectrum. Chemical composition of most stars, 73% hydrogen, 25% helium, 2% other elements. So again, hydrogen, most abundant element. Amount of light a star gives off is its brightness. Rigel shine as brightly as Betelgeuse, even though Rigel is much smaller than Betelgeuse. Rigel is very hot, so each square meter of its photosphere gives off a lot of light. Betelgeuse is fairly cool, so each square meter of its photosphere doesn't give off as much light. So Rigel is smaller, but it's burning brighter. 2 factors determine how bright a star looks from the Earth: how far the star is from the Earth and how bright the star actually is. All right, and that brings us to apparent brightness versus absolute brightness. So the apparent brightness is how it appears to a person standing on Earth, how bright it appears. So you look up at the sky, and some stars stand out, and you're like, oh, wow, that's really bright. Other stars look less bright, but sometimes the less bright star is just really farther away. Absolute brightness is the brightness of a star would have if it were at a standard distance from the Earth. So if you were able to line up all the stars the exact same distance from Earth, and then look at their brightness, that would be their absolute brightness. Star X is closer to the Earth than star Y. Star X appears brighter than star Y. Use the table to answer the following questions. Compare star X with star Y using the term apparent brightness. Star X has a greater apparent brightness than star Y because it appears brighter, so it has a greater apparent brightness. You can't really compare their absolute brightness because you do not know how much farther star Y is from Earth than star X. Star Y could be brighter or not as bright as star X if both were to be seen from the same distance. So it might just be that star X is just a lot closer, and that's why it appears brighter. Closer stars to Earth, the brighter it appears. That's true. Two things must an astronomer find out in order to calculate a star's afternoon: their apparent brightness and the distance from the Earth. That is false. A light year is the distance that light travels through space in 1 year. So it's not actually a year, it's not a time, it's a distance. 9.5 million kilometers. That's what a light year equals. It's a big number. It's fast. Following sentence, true or false? Light year is a unit of time is false. Light year is a unit of distance. Parallax is the apparent change in position of an object when you look at it from different places. So if right now you close your left eye, close your right eye, close your left eye, close your right eye, then the computer screen kind of looks different from each eye. So you're looking at the screen from different places. And the way that it looks, that's one way that they use to determine how far away stars are, by parallax. Also, interesting story, there was a heavy metal band in my high school named Parallax because it sounded cool. 21, astronomers frequently use parallax to measure the distance to which of the following objects nearby stars. 22 is the sun. 23 is the HR diagram, or the Hertzsprung-Russell diagram. That's where we kind of classify stars. Let's see, I guess I don't have the answers there. The x-axis would be the temperature, and the y is the brightness, or it's brightness and temperature. I can't remember. 25 is main sequence. That's what most of the stars are in main sequence. Let's see, 26. Sun is a main sequence star. Rigel is hotter than Betelgeuse. Absolute brightness of Polaris is greater than that of the sun. All right. Sorry I couldn't help you more with 24. If you have the answer, why don't you come on up and I'll let you type it in here so we don't make the same mistake next year. All right. So make any corrections you need to. Add to the wiki and get ready to move on to level 2.